Alright, okay, so today we're going to tackle the topic of what if an object's on a ramp and not flat ground? Okay, so let's say now for this example, we have a cart with some wheels, and we'll say that they're frictionless, and it's sitting on a ramp. So what forces would we have, and what directions would they be? So we would have gravity force straight down because it's on or near a planet, and the normal force is perpendicular to the surface, so it would go up and to the right. Now, for this box on a ramp, what would be the direction of the acceleration? Well, the acceleration would be down and to the right, because when the cart is free to move, it's going to accelerate down the ramp in that down and to the right direction. Now, in a traditional math class, which way would positive x be? So positive x is often in the right direction, but this causes a problem in physics class because what have we said about the direction of the acceleration as we solve through with problems? Well, we've said that these problems are best solved if acceleration is all in the x direction. But that's clearly not what we have in this case. So what could we do to make the acceleration in the direction of positive x? Well, if we want acceleration in the direction of positive x, we could just turn our coordinate axis so that positive x fits in the direction of the acceleration. So now that means our reference angle for the gravitational force is that angle between gravity and positive x. We are given 20 degrees as the angle that the ramp rises, and that's often what you'll be given. So what is this angle between gravity and positive x? Well, to do that, let's look back over here. So there's our gravity force, there's our normal force. Notice that what we have here is a right triangle, and this angle would be 90 down here. So that means this angle up here is the complement of 20 degrees, or that would be 70 degrees, which is also the angle that we have between gravity and positive x on our free body diagram. Okay, so here's an example where we're going to actually work out a problem. So in this example, we have the ramp rising at 1.9 degrees, and remember our reference angle is the complement 88.1 degrees. So we've tipped our free body diagram, and now when we look at it, when I tip this to positive x, notice that gravity goes down and to the right, and the normal force points straight up. If we want to solve this and actually find out what the acceleration is, what's the first equation that we should use? What's the first line of our problem? So the first line we're going to do is sum of the forces in the x equals mass times acceleration in the x direction. And we're doing that because we want to find the acceleration in the x, and we have some value with forces. So what forces are in the x? Well, normal's not in the x, it points straight up, but gravity is, but not all in the x. So we have g cosine theta. What is the gravity force equal to? Well, the gravity force is equal to little m little g, and then we notice that the mass of the cart actually cancels out in this case. Now we have to substitute in our numbers, and we can put in that the acceleration to gravity is 9.8, and we put in our angle, our reference angle, 88.1, and we find the acceleration of the cart would be 3.25 meters per second squared. All right, so do you think that that tip trick will actually work in real life? Here, watch and find out. Flat truck, right?
No, I can
Nope, on the ramp again.